me see how this works. Okay, this is part of the work that we have been doing for Vulkan, and now adding Vulkan encoders. So the question here is possible to have a base class for encoders, or more specifically for H264 encoder, for being used by accelerated hardware accelerated encoders. Nowadays we have the decoders. We have a base class for different codecs, and we have different implementations for that base class. These are the implementations we have, for example, for the H264 decoder base class. But the problem is that encoders are different because in decoders you have the spec, and you decode that spec almost completely, or as much as possible, depending on the profiles. But in the encoders, each hardware implementation implements a subset of the specification, and also there are different hardware limitations that have to comply. So it makes it a little bit tricky, or perhaps difficult to think about a base class for this. But nowadays we have the FFmpeg case, where they took the VAPI encoder for H264 and isolated some functions, and now that those functions are used either by Vulkan and for VAPI, and also partially by D12 encoders. So I was wondering if I can do basically the same, rip off the code that Yoon-Jan did for the H264 encoder, and implement a base class that can be configurable, so we can be reused by other hardware accelerators. In this case, the events will be more or less the same. The subclass, which is the implementation with the hardware acceleration, set to the base class the hardware limitation, that is the list size for either 1 or 2, well, the list, the B-frame support, the number of reference that it supports, and so on. Then the base class, this is the most important function, will generate a GOP structure that is a map where is the IDR, the first frame. The second frame will be either a P, an I, or B, depending on how it's configured and how it's supported by the hardware implementation. And then it will propose a set of parameters, the SPS or the PPS in the case of the H264, and also will provide the limits, the bitrate limits and the levels by the table A1 in the specification. And then the subclass will modify these structures depending on the problem, but you have to be carefully to avoid modify again the GOP structure. And finally, the base class will, well, the base class will call the implementation class for do the actual encoder with the reference list and the slice header to be used. So this is the sequence, more or less. The base class, arrive a new frame, then propose a new sequence. The implementation will provide the profile and level. It provides or propose a new parameters. The modified parameters will be sent back, and then a new output, and then encodes the frame. These are the properties that the base class will offer to the user, though these properties can be modified in runtime depending on the limitations of the hardware and the construction of the GOP, depending how it is produced. The ID period, the B frames, the number of I frames, the number of references of if enable the B pyramid. This is the virtual methods I've been thinking of. That is a new sequence. There's a new parameters. Prepare a new frame, encode the frame, prepare the output, and reset if you want to reset the whole state of the encoder. But there is some pending things. Basically, I don't have any plan to add SEI message support. And also, this is a thing that I would like to think deeper, because nowadays there's only a static fixed GOP, and there's no look ahead. There's no second pass. So how we can have an open GOP or change a GOP in real time according to the sequence we are reading. So that's pending. But I guess this could be a base class simple enough to be adopted by other encoders, hardware accelerated encoders, and for there start to work on. And that's it. Thank you.